Hello. This presentation will cover a critical part of project management, project progress and performance. The focus is on how projects are measured and evaluated to ensure they stay on track. The key concepts from Chapter 13 of the course material will be covered, highlighting the tools used to move from subjectively thinking a project is on track to objectively knowing it is on track. When discussing measuring a project, what is actually being measured? It boils down to three core components. First, cost. This is the most obvious. The actual cost, AC, is tracked against the budgeted baseline, plan value, or PV, and compared to the value of the work actually finished, earned value, or EV. Second, schedule. Is the project on time? This component measures progress against the planned timeline, determining if the project is ahead, behind, or on track. And third, performance. This is the technical side. Is the product being built correctly? Is it meeting the required specifications, like weight, speed, or reliability? It doesn't matter if a project is on time and on budget if the resulting product doesn't work. All three are needed to get a complete picture of project health. This all fits into a continuous four-step loop, the project control process. It starts with step 1, set baseline. This is where the plan is established, the official, approved plan for scope, schedule, and cost. This baseline serves as the ruler for measurement. Next, step 2, measure. As the project runs, data is collected on what is actually happening. What is the actual cost? How much work is actually done? Then, step 3, compare. The measured data is then compared against the baseline plan. This is where variances, differences between the planned and reality, are found. Finally, step 4, take action. Based on those variances, decisions are made. If the project is over budget or behind schedule, corrective actions are implemented to get back on track. If the project is performing well, the reasons can be analyzed and applied elsewhere. Then the loop repeats. The baseline has been mentioned, so it's important to be clear on what it is. The what is that the baseline or plan value, PV, is the anchor point. It's the time-phased budget. It's not just a single number, like $1 million. It's $1 million spread out over time. It shows exactly how much was planned to be spent by any given point in the project. The why is that nothing can be measured without it. The baseline is what allows performance to be measured by calculating those variances, cash flows to be forecasted, and, very importantly, the project status to be objectively evaluated. It is the official plan that performance is measured against. To do this, a system called Earned Value Management, or EVM, is used. These are the three most important terms to know. First, PV, plan value. This is the budgeted cost of work scheduled. Think of it as, based on the plan, how much work was expected to be done by today and what is its budget? Second, AC, actual cost. This is the actual cost of work performed. This is the simple one. How much money has actually been spent to date? Third, and this is the most important concept, EV, earned value. This is the budgeted cost of work performed. This is the value of the work that has been completed, measured in the original budgeted dollars. The key is to compare these three. For example, if EV is higher than AC, more value is being obtained for the money spent. If EV is higher than PV, work is being completed faster than planned. By comparing those three terms, the two primary variances are derived. Cost variance, or CV, is simply EV minus AC. It answers, is the project over or under budget? A positive number is good. It means the earned value is greater than the actual cost. A negative number is bad. It means the project is over budget. Schedule variance, or SV, is EV minus PV. It answers, is the project ahead of or behind schedule? A positive number is good. It means the earned value is greater than the planned value. More work has been done than planned. A negative number is bad. It means the project is behind schedule. Variances are good, but indexes are often even better because they provide a ratio, a measure of efficiency. Cost Performance Index, or CPI, is EV divided by AC. This shows how efficiently money is being used. A CPI of 1.0 means the project is exactly on budget. A CPI less than 1.0, say 0.8, means it's over budget. Only 80 cents of value is being generated for every dollar spent. Schedule Performance Index, or SPI, is EV divided by PV. This shows how efficiently time is being used. An SPI less than 1.0, say 0.9, means the project is behind schedule. It's only progressing at 90% of the planned rate. So, these two indexes, CPI and SPI, can be placed on a simple 2x2 grid to instantly see the project's health. The worst case is in the bottom left, a negative CV, over budget, and a negative SV, behind schedule. This is the red zone, and it requires immediate action. The ideal case is in the top right, a positive CV, under budget, and a positive SV, ahead of schedule. This is where every project manager wants to be. But the mixed cases are also very common. A project could be over budget but ahead of schedule, CV/SV+. Perhaps expensive overtime is being used to get things done fast. The question here is that speed worth the extra cost? Or it could be under budget but behind schedule, CV+/SV. Perhaps the project is being very efficient with money, but not enough work is getting done, possibly due to resource delays. Both of these mixed cases require a closer look. The real power of EVM isn't just looking at the past, it's about forecasting the future. Using current performance and EAC, or estimate at completion, can be calculated. This forecasts the new total cost of the project. If the CPI is 0.8, one cannot just assume the rest of the project will magically be on budget. The EAC provides a realistic, data-driven new total. From there, the VAC, or variance at completion, can be found, which is just the original budget, BAC, minus the new forecast, EAC. This tells exactly how much over or under budget the project is expected to be when finished. Finally, the TCPI, or To Complete Performance Index, is a critical management tool. It calculates the exact efficiency, the CPI, that must be achieved for the rest of the project just to finish on budget. If the TCPI is 1.2, it means the team must be 20% more efficient from this point forward than planned, which is a very high bar. As mentioned at the beginning, cost and schedule are only 2/3 of the story. Technical performance must also be tracked. This chart shows a generic TPM. The goal for this project might be to reduce a product's weight. A target is set, the top right final goal, and progress is tracked at key milestones: design, prototype, test, etc. TPMs like this provide an early warning if the product is in trouble, even if the project seems to be on schedule and budget. They prevent a successful project from ending with a product that doesn't meet its fundamental requirements. Finally, 2 common pitfalls to watch out for. The first is scope creep. These are the small, unmanaged changes that just get added on. Can you just add this one button? Can you make this report in a different color? Individually, they're tiny, but they add up, and without a formal change control process, they will destroy the cost and schedule. The second is baseline changes, or what's sometimes called a rubber baseline. Changing the baseline is a big deal and should only be done for major, approved changes in scope. It should never be used to hide poor performance. If a project is over budget and behind schedule, the baseline isn't just moved to make the numbers look good. That's just moving the goalposts, and it defeats the whole purpose of project control. That concludes this summary of project measurement and evaluation. It has covered the 3 components of measurement: the control process, the core concepts of earned value management, and how to use them to both interpret current status and forecast the future. Thank you for your attention.